When the angles are in Cartesian coordinate system, they are angles in standard position. So first let me draw the Cartesian coordinate system. That is our 4-quadrant system. So let this be the y-axis, let this be the x-axis. So this will be positive x-axis and this will be negative x-axis. This will be positive y and this will be negative y-axis. So let this quadrant system have an origin O. So this will be the first quadrant, this one will be the second quadrant, this one will be the third quadrant and this one will be the fourth quadrant. So let the initial position of the ray coincide with the x-axis, that is here, and let the ray be named as OA. This will be the initial position of the ray when the ray is rotating in an anti-clockwise direction. That is like this. When the angle of its rotation be from 0 to 90 degrees, it is said to be in first quadrant. If the ray is rotating in a clockwise direction, if its angle falls in the first quadrant, that is this part of the coordinate system, it is said to be in first quadrant. So this will be its first 90 degrees and this one will be its second 90 degrees, that is 90 plus 90, 180, and this portion will be its third 90 degrees, that is 270 degrees, and from 270 degrees it comes back to its initial position, that is 0 degrees or 360 degrees. So when it is rotating in clockwise direction, if it falls from minus 270 degrees to minus 360 degrees, it is said to be in first quadrant. Here minus sign is given because of its clockwise rotation. In the first case we have seen it to be rotating in an anti-clockwise direction. In the second case, that is in green, it is rotating in a clockwise direction. So all the angles from 0 to 90 degrees and from minus 270 degrees to minus 360 degrees are said to fall under first quadrant. So next one is, if this line is 90 degrees, then this line will be the 180 degrees. Here we are still considering the initial position of the ray to be OA. So if it is rotating from this initial position, when it stops anywhere between this 90 degree line and this 180 degree line, that is 90 degrees to 180 degrees, it is said to be in second quadrant when it is rotating in an anti-clockwise direction. This quadrant also measures 90 degrees. So this line forms a straight line, so this measurement will be 180 degrees. When it is rotating in clockwise direction, from here to here it will be minus 90 degrees. From minus 90 degrees it is forming a straight line with its initial position, that is OA. So it will be minus 180 degrees. Minus 180 degrees to 270 degrees. When the angle falls from anywhere minus 180 degrees to minus 270 degrees, it is said to be in second quadrant. For the third quadrant, when the ray is rotating in anti-clockwise direction and when its final position be anywhere between 180 degrees to 270 degrees, it is said to be in third quadrant. And when it is rotating in a clockwise direction, it will be minus 90 degrees, and from minus 90 degrees to minus 180 degrees. Minus 180 degrees is forming a straight line. When the ray is rotating in a clockwise direction, if its final position falls anywhere between minus 90 degrees to minus 180 degrees, it is said to be in third quadrant. And at last, for the fourth quadrant, when the ray is rotating in a anti-clockwise direction and when its final position falls anywhere between 270 degrees to 360 degrees, it is said to be in fourth quadrant. When it is rotating in a clockwise direction, when its angle fall anywhere between 0 degrees to minus 90 degrees, it is said to be in fourth quadrant, this part of the quadrant. So when the angles are represented in this manner, that is when its initial position coincides with the positive x-axis and when its final position of the ray falls anywhere in one of these 4 quadrants, that is it may be 45 degrees, or if it is 100 degrees, or when it comes to third quadrant if it is 250, and for the fourth quadrant if the angle is say 300 degrees. When it is represented like this, the angles are said to be in standard position. That is, when the angles are represented in Cartesian coordinate system, then the angles are said to be in standard position. You can also write it down here. Let me write down all the 4 quadrants here. First quadrant, second quadrant, third third quadrant and fourth quadrant. And we have two types of rotation of the ray, that is anti-clockwise rotation and clockwise rotation. Anti-clockwise rotation is always represented as a positive number and clockwise rotation is always represented as a negative number. So we can make a table. So for the first quadrant, when the angle is between 0 to 90 degrees, it is said to be in first quadrant. So when it is rotating in anti-clockwise direction, if it is rotating in clockwise direction, then the angles are between minus 270 degrees to minus 360 degrees. They are said to be in first quadrant. In terms of phi, it will be 0 radian to pi by 2 radian, and here it will be minus 3 pi by 2 radian to minus 2 pi radians. Similarly for second quadrant, when the ray is rotating in an anti-clockwise direction and if its angle fall from 90 degrees to 180 degrees, that is from pi by 2 radians to pi radians, it is said to be in second quadrant. If it is rotating in a clockwise direction and if its angle fall anywhere between minus 180 degrees to minus 270 degrees, in terms of radians, minus pi radians to minus 3 pi by 2 radians, it is said to be in second quadrant. Similarly for the third quadrant, when the ray is rotating anti-clockwise, when its final position fall anywhere from 180 degrees to 270 degrees, in terms of radians, pi radians to 3 pi by 2 radians, it is said to be in third quadrant. When the ray is rotating in clockwise direction, when its final position fall anywhere from minus 90 degrees to minus 180 degrees, in terms of radians, it is minus pi by 2 radians to minus pi radians, it is said to be in third quadrant. Similarly for fourth quadrant. So always in all these cases, its initial position will always coincide with the x-axis. The ray, when it's rotating in an anti-clockwise direction and its final position fall anywhere between 270 degrees to 360 degrees, in terms of radians, 3 pi by 2 radians to 2 pi radians, it is said to be in fourth quadrant. And when it is rotating in clockwise direction, if its angle fall anywhere between 0 degrees to minus 90 degrees, in terms of radians, it is 0 radians to minus pi by 2 radians, will be in fourth quadrant. So when we look into these values, a doubt may arise in our mind. That is, what if when the angles are more than 360 degrees? There is a term called coterminal angles. So if the angle is theta and its other angle be in the form of theta plus or minus n times 360 degrees, they are said to be coterminal angles, where n is a positive integer. When theta and its other angles fall under this criteria, the angles terminal will be the same. So let me take the example of theta to be equal to 45 degrees. First, let me take the anti-clockwise rotation. So 45 degrees plus 360 degrees into 1, which will be equal to 45 degrees plus 360 degrees, which is equal to 405 degrees. Next, let me take the example of clockwise rotation. 45 degrees minus 360 degrees into 1. This will be equal to 45 degrees minus 360 degrees, which is equal to minus 115 degrees. Let me take another example of anti-clockwise rotation for the same 45 degrees. So 45 degrees plus 360 degrees into 2. This will be equal to 45 degrees plus 720 degrees, which is equal to 765 degrees. When we see these angles in the standard position, let me draw the four quadrants. Let this be our origin O, and this will be the initial position of the ray, that is OA. Its terminal position, that is final position of the ray OB, makes an angle of 45 degrees, and this angle is in first quadrant. When we use this criteria, we can see that first it is making 360 degrees complete rotation in an anti-clockwise direction. So 360 degrees plus 45 degrees, which is here. So this angle will be 405 degrees, and it is having the same terminal side. Next one is clockwise rotation. So this ray is rotating in a clockwise direction from its initial position, OA. It is making 315 degrees, which will be in the first quadrant. Minus 90 is minus 180. Minus 90 plus minus 90 is minus 180. Minus 180 minus 90 is minus 270. Minus 270 minus 45 is minus 315 degrees. So this anticlockwise rotation of the ray is same terminal side OB. Fourth example is 765 degrees. So it is making two 360-degree rotations. So this is anticlockwise rotation. First 360 degrees, second 360 degrees plus another 45 degrees. So this will be 765 degrees. This angle is also having the same terminal side OB. We can say that these are all co-terminal angles. That is angle 45 degrees, 405 degrees minus 315 degrees, and last one 765 degrees. This list will be keep on going. So here we have taken only 4 examples. These 4 example angles are said to be co-terminal angles. So co-terminal angles involve angles that are more than 360 degrees and the angles that are less than 360 degrees, and negative angles, that is the angles which are rotating in clockwise direction. And the second type of doubt which may arise in our mind is that first quadrant is also having 90 degrees and the second quadrant is also having 90 degrees. So when the angle is 90 degrees, which quadrant to consider, first quadrant or second quadrant? And similarly for 180 degrees. So second quadrant is having 180 degrees and third quadrant is also having 180 degrees. Similarly for 270 degrees, third quadrant is also having 270 degrees and the fourth quadrant is also having 270 degrees. And similarly for the clockwise rotation. So first quadrant and second quadrant have minus 270 degrees in common. For the third quadrant and fourth quadrant, they have minus 90 degrees in common. So when the angle is 90 degrees or 180 degrees or 270 degrees or minus 90 degrees or minus 270 degrees, which quadrant to consider? For that, there is a term called quadrant angles. So when the angles are 0 degrees or 90 degrees or 180 degrees, 270 degrees, and their co-terminal angles, that is theta plus or minus n of 360 degrees, where n is a positive integer. These angles are called quadrant angles. When we take the angle 90 degrees into consideration, 89 degrees, that is somewhere here, it is said to be in first quadrant. When the angle is 91 degrees, that is somewhere here, it is said to be in second quadrant. But when the angle is 90 degrees, it is said to be a quadrant angle. In this video, we learnt about angles in standard position. That is, when the angles are represented in terms of Cartesian coordinate system, will fall in first quadrant, second quadrant, third quadrant, or the fourth quadrant. Next, we learnt about coterminal angles. Angle theta along with its other forms, that is theta plus or minus n 360 degrees, are said to be coterminal angles. Lastly, we learnt about quadrant angles. The angles 0 degrees, 90 degrees, 180 degrees, 270 degrees along with their coterminal angles are said to be quadrant angles. If you understood the concept, subscribe to the channel and like the video. Thank you.